This video will discuss a particular aspect of Brexit using game theory and incomplete information. The issue concerns the taste of chocolate after Brexit. Currently, Cadbury's chocolate is produced in Birmingham by the American-owned company Mondelez. Under the European Parliament and Council Directive 2036 EC, all milk chocolate made for consumption in the UK must have a minimum cocoa content of 20%. This is high, however, compared to US federal relations standards, which requires a minimum cocoa content of 10%. My concern is that following Brexit, if the UK fails to introduce similar standards, then Mondelez may reduce the cocoa content in their UK chocolate and divert closer to US measures.
This issue is important, since experiments with Brits and Americans have confirmed a significant taste difference between chocolate with different amounts of cocoa, meaning changes to Cadbury's recipe will not go unnoticed. Furthermore, in 2017, the UK market for cocoa, chocolate and sugar confectionery goods generated a significant turnover of £4 billion. Britain is a nation of chocolate lovers. In 2015, it was estimated that the average British consumer consumed around 16.3 pounds of chocolate, the fourth highest amount in the EU. If the taste of this popular good changes, then domestic demand and sales could freeze up, bringing negative consequences to consumers, companies like Mondelez and the wider economy. In terms of the game, the actions for Mondelez are keep or change recipe, and the British consumer can choose to accept or protest. However, the related payoffs will depend on the consumer's taste preferences, which defines their type. Since this is personal to each consumer, Mondelez will not know the type of consumer prior to them making their decision, and this generates incomplete information. To solve the game, we use the concepts of extended beliefs and randomized types introduced by John Harsanyi.
Using extended beliefs, we consider the types which Mondelez believes the British consumer will take, notably HC where the consumer prefers high cocoa taste and LC where the consumer prefers low cocoa taste. Randomised types means that the determination of the type of consumer is decided at random by nature, with probability P that the consumer is HC and probability 1 minus P that the consumer is LC. The probability distribution is common knowledge. The game is simultaneous, so each player does not know the action of the other before deciding themselves. It is modelled by the two following payoff matrices.
If nature determines the consumer to be HC, the highest payoff for the consumer is 10, and is gained when keep current recipe except is played. Here the cocoa content remains high. Mondelez's payoff is -5, assuming that keeping the higher content means higher costs. If the HC consumer protests, then their overall payoff falls to 5, since they actually prefer the higher cocoa taste, whilst Mondelez's payoff falls to -10, given the inconvenience of protests. If Mondelez change their recipe and the HC consumer accepts, the consumer yields their lowest possible payoff of -10, since their preferred taste is abandoned, whilst Mondelez yield their highest payoff of 10 from the cost reduction. In the last scenario, the HC consumer protests against the changed recipe, and their payoff is -5, since here they gain extra benefit from protesting, but Mondelez's payoffs are reduced to 5. For the LC consumer, payoffs follow identical reasoning, but they instead yield positive payoff from a recipe change and negative payoffs from no change. Payoffs for Mondelez are the same.
To solve, we set P equal to 2 over 3 and calculate the expected utilities for the 8 potential outcomes, consisting of the 2 actions of Mondelez and the 4 strategies which the consumer can play depending on their type. For example, if Mondelez plays keep and consumer plays AA, then their expected utilities are -5 and 10 over 3 respectively, with calculations shown on the slide. Following this method for all outcomes, we yield the table of expected utilities. Using the concepts of Nash equilibrium, we identify change PA with the associated payoffs 20 over 3, 0 as an optimal solution, since at this outcome, neither player will want to move given the other strategy. In terms of comments and lessons, the consumer should protest if they are HC and accept if they are LC, although the payoffs will be different for each case. Mondelez should definitely change their recipe, but will gain a higher payoff if the consumer is LC, since they will not have the inconvenience of protests or a potential reduction in demand. If the consumer is LC, then both players will gain their maximum payoff of 10.
To extend the game, a wider variety of preferences can be considered, alongside a p-value which is selected based on market research to represent society's preferences more accurately. In the case of incomplete information, the solution and payoffs for both players is dependent on the type of player participating, which amplifies the significance of behavioural aspects in gaming situations. Realistically, in most situations, there is likely to be some form of incomplete information, and this process helps to model such games. The concept of nature can also be used to model other aspects of uncertainty, besides player's type. For example, the outcome from the flipping of a coin, which is purely determined at random with no influence from participants, but has a known probability distribution. Thank you for watching.